Hey there, this is Modern Retro Tech, and today we continue in our Elixir adventures. We will continue with the Wiktionary, local Wiktionary apps that I was doing. Sorry for a little delay, I was off last week because I got a bit sick. Now I'm feeling fine again, and I'm very excited to continue our Elixir journey. So without further ado, let's do a quick recap, and then we will continue with parsing Wiktionary articles. So here you can see the apps that we did last time. I will make the font a bit larger. I will make the browser a bit smaller. Yep. So what are we doing here? We have Wiktionary articles. For example, we can search for the German word Käse, which means cheese. And here you can see that Wiktionary provides definition. It provides a bunch of usage note, it provides declension, so grammatical information, derived terms, etymology, and a bunch of other interesting information. Now, Wiktionary itself is not a very friendly way to search for words, and often we need to, searching is quite annoying, plus it's not the exact stuff that I want to see when I learn the language. So I want to simplify it a bit, and I want to have local cache with this stuff so that it's a bit faster and easier to find stuff that I want. Last time we did this very little app. Here is essentially articles that we download from Wiktionary when we search for some word. And when we change stuff here, you can see that we try to get some other articles, for example, for Latin letter K in this case. And if you go here, you can see we are back on the article. We have specific setup for this search field. We are using LiveView to search for stuff. And due to the bounds settings that we set, we are not overloading Wiktionary with our queries. Now, the next thing that we need to do is to be able to actually parse the articles we received to show them in a bit nicer form than just rendering HTML that we get from Wiktionary. Last time, for that, we started to work on this function called parse article. And this function is pretty cool, but it is quite complex. And I started writing it in the LiveView module itself. So I think the first thing that I will do today is separating it into its own module. And then we continue with parsing logic, and we will try to simplify it, and hopefully, if we will be able to finish it in the next 2 hours, we will start also working on some UX for the parsed stuff that we will have here. So for that, we will need to create a new file. So in Wiktionary app itself, we can create a new app. Let's call it just Parser. And here we can define a module. So now we can take the logic we implemented last time. There is another bit of logic that we have here where we start a task that actually downloads the article we need with HTTP poison, doing it asynchronously, and then sends information back to our LiveView. For now, I will keep it here for simplicity, but this stuff we will move. So we'll move it here. Yeah, everything will be broken now for a second. And here, do we need any imports? I don't think so. I think the main thing now is, and I think we don't even use parse article here yet. No, we don't. So the main thing is, yeah, we have this little function test dictionary article that we also don't use. For now, I will move it in the same spot where we will do our parser. And we should get an easy time in our REPL now to be able to see what we actually get there. So let's do article, and we say, oh, sorry, let's first do alias of our Wiktionary parser. And then we can create an article. So we can say parser test Wiktionary article. So we got a string with HTML now, and then we can try to parse it with our function. I don't remember what I was doing last time already, so we'll need to do a bit of research to see what we actually get from that. Parse article, article, parsed article, right? So we get a bunch of stuff here. The last time, one of the complexities was that we actually, the way the HTML is structured on Wiktionary articles is not very easy to parse. In essence, we just get like a list of all those elements without any like relationships between them. So some of that is some elements are children of other elements, some elements are not children of other elements. In general, this is not very semantic HTML, so it's a bit of a mess, and it may be a bit annoying to parse precisely because of that. What I was doing, I was extracting language blocks. So typically those articles can have several things, several languages. So if I go to Angst, you can see that it's a word both in German and in Plattdeutsch. So we need to separate those languages, and we need to able to select only the part of articles that is relevant to the language we are using. So here, I want to look at the parsed article again to see how far we get. So we get Plattdeutsch, we get German, and actually it looks kind of okay already, I think, right? We have edit section etymology, we get I wonder if we get pronunciation here. Yeah, we get pronunciation here as well. So it seems that we actually get the stuff that we need. Now, one comment that I have here is that we need to do 3 levels extraction, which is interesting to see, but I am not sure if that doesn't happen already, because the code that I get looks like that. Now, one thing that I think will be easy for us to do is to try to already show the stuff in LiveView, right? So reconstruct back HTML from the stuff that we got here in our language blocks. And I guess we can already convert language blocks to a map, right? I also wonder if that will work with one language articles, but that we can test later on. For now, we can assume that it will and just do a conversion. So take language blocks and we create a map out of it. So that should be quite easy. We can now recompile, and then we should be able to get parsed article again. Something broke. So what did break? Oh yeah, because we get this list where you write language, language name. So instead, I would remove this stuff and just made it a tuple of 2 elements. So now we should get a map with 2 keys, German and Plattdeutsch. We can check it with map keys. Exactly. And then we should be able to do that. Okay, it looks correct to me. So it doesn't like something here. Variable accumulator is unused. Okay, sure. And for now, I prefer to write specs, because otherwise I get really confused about what I'm doing sometimes, especially if the logic is complex. So I wonder what this stuff, what Flocky returns. Does it have some kind of type? Oh, it defines the type HTML3. So we say, oh no, article is even string, right? So we have a string and we get a map from language, which for now will be also a string. Oops, I think I should write it down like that. Language, and that is mapped to flocky HTML tree. I think, yeah, okay. I already even forgot the syntax for type specs. I haven't written Elixir for so long. So we got this. I will for now remove this stuff because we will be using it a bit more often. And now what we need to do, we need to try to reconstruct the article. I wonder if Floki provides a method for that. We can check it out. So I would imagine we'll see some documentation here. What is that? It's not what I want. Okay. Flocky. I guess it's, come on, online documentation, yes. So here we will have functions, and we get functions for like attribute, children, filter out, parse, raw HTML text, and we get parse document and stuff like that. So Floki only parses this stuff. It doesn't really extract HTML. So we will need to do some kind of HTML regeneration, I guess. For simplicity, I will be writing it in this module too. We can later on refactor it to be in another module, but for now that should be sufficient. So let's say reconstruct, or even why do we need such just two HTML tree, and it will return a string, right? Okay, sorry, I cannot try to type like that. I need to write it like that. So that's Floki HTML tree, and that is a string. If you look at that, we can see that Floki follows, thankfully, a very nice abstraction. So it uses tuples. It uses 3-element tuples to represent the tag, the attributes of a tag. So for example, here you can see name of the attribute, value of the attribute, and then a list of children. So that in principle should be sufficient for us to reconstruct an actual HTML from that. I don't see any kind of weird stuff here so far. So we can just try to create a string from that and render it in our LiveView application. So, and by the way, HTML tree is also something, it can be a list. So if it's a list, we will need to recursively apply it to itself, right? But first, let's start with something simpler. So let's take this thing as our test case. And see if, so we will have a function with multiple heads. This is our first head, where we will have tag, attributes, and children. And then, and by the way, I think we can even see it here. It says a list of HTML nodes. So if we get that, what do we need to do? We need to essentially create a string where we have, so we have a tag, here, let's first say, so if that is empty and that is empty, we just do this. Then if, I can actually also make it a bit shorter. If we have attributes and children, no, if we get just children, then this will be so we will say children, and here we will say children equals to tag to sorry, I'm so dumb. Enum map children to HTML1, right? Okay. Finally, if we have the same thing but with attributes, we will need to create an additional function to HTML attribute, where we had attribute, which will be name and value tuple, and here attributes so we get attributes here. Oh, I forgot one thing here. So we need to join them. And for attribute, we need to also actually join them, right? But this time we will need to add space. And here we will need to, okay, into attribute, what we are doing, we will also generate this stuff. We are taking the name, and then we are taking the value, but, oops, that will be this kind of string, because we need to put quotes here. I'm doing something really dumb, I guess. Oh yeah, because that stuff requires us, yeah, I remember. Okay, in Elixir there is a better way to do that. We have this sigil, where you put the tilde s, and then you don't need to use quotes in your string. You can just use them like normal symbols inside the string. So, and here we just get value. Oops. And then if attributes, yeah, I want to check if enum join this. It should be empty string, right? Yes. So if so case attributes to then it's empty string, and if it's non-empty list, then we do that. And we also need to add a space to separate it from the tag itself. So something like that. Actually, then this function we don't need. So, and children to HTML join to HTML attribute we did. So then we can say tree. We can take this stuff. And then we can try to call, we can do recompile. And we can call our parser to HTML tree. And some, oh yeah, we forgot that it actually is also a list of stuff. So let's try it again. Okay, we broke because we also get just plain text here. So another thing that we need to handle is text, is binary text to. Now, one thing that we do not very well here is that I'm just concatenating strings. And doing that for simplicity, Elixir has another cool feature called IO lists, which you can use to make it more performant. We essentially can add elements to the list without recreating strings and allocating stuff on the heap and stuff like that. Reallocating stuff on the heap more precisely. But for now, we are going with the simplest possible approach. And to be honest, I don't think concatenating those HTML attributes will be such a big problem for us. If it will become, we can always optimize. But for now, it's the easiest approach that we will go with. For text, actually, I don't need even to do end block or anything like that. I can just go for text. Okay. Now we can try to recompile again, and we can try to parse the tree. And we got our stuff, right? To make it look a bit nicer, we can do the outputs. So that looks like a valid HTML to me, which is nice. So we can add it a bit here to our test case. Oops, I actually wanted to copy this stuff. Now, next thing that we need to consider, let's try to take the bigger thing. So we had parsed article, right? Let's take German part of that. Article is parsed article German. Remember that was a map. So we got that. So our input is this stuff. And now we can actually do, okay, that's easier to write. So we do German article, and then we do IO puts. And we got some weird looking stuff. But in general, it looks okay to me. Oh my God, they literally just inline CSS there. I didn't notice it before. That looks a bit funny. There is like a bunch of stuff. But that is already sufficient for us to test, right? We can now try to render in our LiveView. We can just render the stuff for the language we care about. Or like for now, since we're still debugging this stuff, I would probably render actually both things, but I will render them in a way that we will just write headers ourselves for each thing. So after it get, first of all, we will need to, of course, depend on parser here. So when we get article, we get definition, request ID, and body. And right now we just assign body itself to definition, but let's call it languages map. And in essence, what do we need? We do parse article. We get the body. That should be our languages map. Then for each of those, we do in our map and we say, what do we do there? We just do language article, and we actually can just keep it like that. The only things that I care about here is about running stuff through our reconstructor, right? So, by the way, to HTML attribute is an inner method that we should never actually use in other modules, so we can do it like that. So for now, we just, it feels a bit silly, right? Because we downloading stuff and then we just parse it and then we put it back into HTML. But the idea is for now to check that what kind of parsed HTML tree we got. And we already extracted separate languages. So that's also an important part of that. Now we can actually pass both, right? So we have our original body and we have our languages map. And now we need to render it in our template. So I will still keep our old stuff where we have things. By the way, I think, shall we already start doing BAM? Yeah, if you haven't heard about BAM, BAM is a really cool CSS thing that essentially is just a naming convention for CSS. There is also a JavaScript library, but I usually don't use it. The main thing for me, BAM gives you a structural way of writing CSS. So you know what is inside what, which things you can move where. It allows you to create independent styles. So it's pretty cool for that. And in general, it allows you to structure your CSS logic way better. I will do, I guess, a separate edited video about BAM because it's a pretty interesting topic and something that, at least for me, made me way happier about CSS in general. But for now, I won't concentrate on that much. The main thing to know, they split stuff into blocks, elements, and modifiers. So block is something that is like meaningful entity. So it may be a search box, it may be a button, something like that. Element is part of that meaningful entity, and modifier is some kind of attributes. For example, you have buttons that are like danger attributes, or like something like remove repository on GitHub, it's red. And in like Bootstrap, you would apply specific style for changing the color. In BAM, you will have like semantic attributes. So you, and then you use different naming conventions for blocks, elements, and attributes. So blocks are Latin letters, digits, and dashes. Elements are block name separated by 2 underscore and then element name. And in element name, we also use singular underscores. And in modifier, we have double dashes after block or block and element name. And also use single dashes for the modifier names. There are specific rules you should not, for example, use tag names or IDs in your CSS. You need to use only class name selectors. You shouldn't depend on other blocks or elements on a page for block and elements. And for elements, you essentially, blocks, elements, and modifiers, you just use the whole block element or block element modifier. Block modifier, block element modifier combinations of selectors. So it can sound a bit abstract, but it will become a bit clearer once we start working on that. So fixed container is element. So I need to change it to look like that. What have we defined? We just defined the width and we defined the height. We can reuse it for now. So we can say That's fixed container. And here we essentially need to do what? We need for each language article in our assign, which is called languages map. Oops. Need to generate, for now we can just generate the language scene, right? So I will just use h1. And here I can then inline my language. Languages map not available. Handle info. Oh yeah. So for now we'll set it to that. Yeah, because empty state was invalid. So now we can try to search for our favorite word. And you can see that we successfully rendered German and Plattdeutsch. To make it look a bit cleaner, I will for now comment this stuff out. So you can, did it actually work? I think sometimes when we use EX templates or LEX templates, the stuff just doesn't, like HTML comments don't seem to work. Okay, maybe I can do it like that. Or like, I don't know. Ah, that's the syntax apparently. But it breaks. Splendid. Okay, then what I can do, I can just do this. And here I can just comment this. Oh, come on. I can just comment this stuff out, I guess, like that. It still breaks. Gosh. Okay, you know what? I will just move it somewhere here. And for now, whatever. Oh, of course. We will in sidebar. So that should be better. And now when we search for Angst, yeah, looks good. We can now apply, we can now try to render the thing. Actually, my backup thing did it. So we have this magical command for rendering raw HTML. And here I can use it, so I can just render the article. Let's try it again. Something is not going well. Oh, it's not an assign, it's local variable. So actually it looks kinda, oh dear, Austria. So this stuff looks a bit weird. And we get like a bunch of audio files. Why do we, I wonder? Then we get known, edit, known, edit, edit, edit. Oh, it seems that we have, now I understand what happens. Since we're going recursively through the HTML tree, it means that we are getting children of the element, we render them, and then we get like, we go into the child itself, we render it and its children, and essentially depending on how many layers of inner children you have, you will have a number of repetitions equal to that. So that's why it looks so weird. But you can see it was a good idea to render it quickly, because otherwise it could have taken us a lot of time to figure out what we're actually doing wrong. So now that we can see, and we can try to fix it. Let's look at our parse article function again. Here, that stuff we don't need. We get the tree, we get the div, we get the children, and then we start going through the children. We have language name, staged, and results. For each element, language name. Where recursion happens. I guess it happens inside for all children, right? Yep, it does. So this function is our walker. We take the root of the tree, and then we apply it for each child, and then we go for each node, and we apply it also for each child. We don't reapply it for text. But in essence, now this comment makes sense, right? We need to add tree levels, and we need to put stuff back, which is an interesting thing. I actually don't know how to approach it yet. Let's try to think. One interesting thing that I'm thinking, maybe we should use something like zipper. So not this zipper, but zipper which is data structure. So it allows us to move on like tree-like structures on lists, up and down, depending on the children. And it provides operations like move to the next child, go to the parent, go to the children. So actually, it's kind of a good data structure to use on the tree-like data structures. Now the question is, will it simplify stuff for us if we convert this list of lists to a zipper specifically? We still need somehow to tag stuff in the tree, and we need to be able to traverse it. Let's check out zipper for tree. Of course, we get some Haskell articles, but let's check it out anyways. So they have, this is the tree definition, and then they write functions. They have directions. And then they have a list of directions, which is essentially says where we are in the tree. And then we have functions like go left, go right. Go right, go up. And then they have a function modify. But that's still a bit not what we want, right? We probably don't want to have, after our parsing, just HTML stuff. What we want to have is to extract the text and tag it with different things. Maybe that's something that I need to just mention, because how do I see the end result of our parsing. I want to get, for example, for the first version, I just want to get like the grammatical type of the word and then have like definitions. And I, for now, will ignore all the rest. So like, once I get there, I wonder actually if we duplicate them as well, the definition. Yep, we do. So that's not as simple as having child here. If I look at that, we will see that this stuff are all links and they have also attributes. So that's what creates the why it needs to traverse it. And here it's the same. So we have a list, ordered list of items, and then we have like first item, second item, and then we have inner links. So what I'm thinking, and this list is just goes after h3, which says noun. It has a id noun too, and this has id noun. That's a bit interesting. And then they have a paragraph, and then they have a bunch of grammatical info, and then they have an ordered list of things. So we still need to, like, even if we just go for this very little slice of our HTML tree, which we already can extract, we will still need to somehow deal with reconstructing children and doing all this kind of stuff. Okay, how else can we attempt to do that? I think we first can just try to track the level of the tree via add, right? So when we get our call to fold children, we start with the tree level. Or just level. And we can now add it everywhere, right? So we just ignore comments completely. Here level will be +1, obviously. Here level will be, this is like node. And every time we call the function, we should pass the current level, I think. Right? So like here, to say level, and here we need to pass level. And here, well, we actually don't call the function itself yet, right? Of children, level children accumulator when it is list. Ah, yeah, because there is no node which we have in focus. So let's also give for children proper definition. So it will have level, which is non-negative integer. It has flocky tree HTML. Oh, HTML tree. and it has accumulator, which is anything really. You can even call it like that. And function is we will call it reducer. And what does it take? It take level. Actually, right? And for now, I will just do it like that. Oops, that's of course is not the definition, it's just a spec. And then here, for some reason, I always make this mistake when I try to write types directly here. I guess I wrote too much Rust and ML languages. So that's kind of the things that you do. What does it return? It returns accumulator, of course. So any, actually, if we're going for everything should be typed, though we should do that as well. So accumulator, accumulator. And here's a level HTML3 accumulator reducer. And here we actually then don't need to repeat the names. Right. Right, and that should then fit onto one line, I think. Yeah, it does. So, of course, types we can then move here. So, now our function will need to accept level as well. So now it says the function call will not succeed. Children, nil, breaks a contract level, flocky HTML3, accumulator, reducer. Ah, yeah, because our reducer is not properly defined yet. So that should be a function that takes level and node of the tree and an accumulator. I don't recall actually how to write this type spec. There is a magical table. Okay, so without a fan, we can just do level accumulator. And does it take? Yeah, it takes. Actually, no. Let's just use the flocky stuff. I think that's easier. Flocky HTML3, and it returns accumulator. So now this stuff shouldn't. Variable level isn't used. Yeah, it is. For each element, we do this. So we have like a list of elements in staged and in result. And we can add levels there in principle, right? So level element Man, it looks so ugly. It's so complex. I wonder if you can simplify it. Now everything should break. So let's clean this stuff. And let's do A. Yeah, everything already broke. Because we get this. So now we get levels. At least we now know that we actually got them. And in our list, I wonder if we can actually depend on the level number itself to then select elements, right? Because then we can in principle just say, give me something on level 3. But okay, for now, let's try to think about how to render children. So when we first call to HTML, what we want to do is to extract level. So what I'm thinking about, we can just render stuff on the same level, right? In the tree to remove the duplication. So here, level to use, let's do that like that. So depending if we get a list of nodes, if we get level something, when just return level. Alternatively, we get a list. We can take first and ignore the last. And here, actually, yeah, we can do level. And in all other cases, we can just set it to 0 for now. Or cannot convert to HTML, cannot convert empty tree to HTML. Okay. So we then get level to use, and then we get HTML3 tree, and then we can use this stuff. So level to use, level to use, level to use, level to use. And then actually, so this stuff will also contain levels, but what I will do, in essence, I will just ignore everything that is not on the level I want. Oh man, that looks a bit super complex actually, but what can you do? That's the structure we get from the input. So level to use, and if level whatever, to use is less than level, what we actually return in this case? Just empty stuff, I guess, empty string. Seems so. Then so let's for now say tree with levels, and for now I won't even care. I will just say, or actually no, it's very easy to define, right? We can just say level, and then we have tree with levels, or it's flocky HTML tree. So that's actually the stuff that we get. And of course, then this thing also returns this. Yeah, Idealizer supports recursive types, which is pretty cool. So let's try to check it, I guess, what if it will work. So I'm recompiling, I'm reloading, just in case. Now, so parse to HTML. Oh, because actually so in essence, in our original list we skip stuff. Will we get something else there? I'm wondering. Whoa, this is so mind-breaking. If we go here and we execute this, let's try to first play on a simple example with the stuff. So let's assume, let's do a new tree thing, right? So here we can add this level stuff. So let's just say level, I don't know, 1. This is our span. So how I'm seeing this stuff looking right now? Span. Actually, no, I think it doesn't make much sense, right? Because we still will get all the children everywhere duplicated. I'm wondering if we should maybe look back at the logic that we use for parsing stuff, because here to reconstruction that we already kind of did. Because here we add everything back with levels. And every time we call the function, we will re-add stuff there. Why actually we even going through it? Why cannot we just take the... Because we want to extract new language name, right? We want to extract language names. We want to associate parts of article with language names. But then Oh my God. Okay. We don't need to do it. We don't need to do it at all because we can just take the, we can just do all parsing in this function, right? We don't want to return HTML in the end anyways. So what we can do, we can just add more conditions here to extract stuff that we care about. That won't be pretty, I think, but that would be probably prettier than continuing with this level stuff. I will commit it just in case. So, because if then I change my mind and decide to try that again, then it will be pretty annoying to rewrite it. Levels trial. So let's remove this stuff. So we are going back to previous thing. This we don't need, 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 this we don't need. So this is for HTML3. This stuff we don't need. This body we don't need. This case we don't need. This is that we need. Oh, that stuff we don't need. And here we also don't care about it. And here we don't need that. Okay. Almost there. I need to commit more often than I could have just returned back to the previous state. But now we need to do it a bit manually. Okay. So now something broke. Of course. Okay, it compiles. Let's try it again. So German. That looks so funny. But okay, okay, so we are back to that, and we can then just try to extract stuff that we care about. So currently we just have in our result, we get this language stuff. I'm thinking, let's try to just let's try to get first this list of definitions. Or like even simpler, I guess, would be to get just the noun thing, right? So here we can say that So we know that this is headline. Maybe we can start also to simplify the stuff a bit, because I think, so like fall children is our helper for sure. Here we can add another thing. We can add a thing that will, a function that will essentially contain this body, right? Span attributes. So like this case, like having h2, which contains this stuff, this new language name, that should be the function that extracts the language. So language, how do we call it? Part, language, chapter, article, language section. And in essence, what it takes an element and then it checks. So if we have this stuff, we get new language name and then alternatively it will return nil, I guess. In this case, it will see. So like in this, what do we do? If we have new language name, result when it's list result, language section, language section, language section start, I guess, because this stuff, this block doesn't contain it. Otherwise, it would have been very easy to just select it with CSS selector and then just put it where we want it. Sadly, that's not the case, so we need to do more involved stuff right now. So if we get that, we need to essentially new language name element. Class MW headline. Why do we do that, I wonder? German in span attributes. Alternatively. Because that's also part of this condition, right? So then this name lies because we don't know if it's new language name, which is not possible language name. And then, okay, that's the thing. So if one of the attributes in span is this thing, then we can return tagged node. So language section start with possible language name and element. So that thing essentially extracts extract, I'll call it like that. So kind attribute HTML tree. So that's what we will be extracting then, right? Attributes. I actually want to make it a bit more generic, maybe. Well, for now, I will just say attribute. We will see how much stuff we actually need, because maybe we always just do text. And HTML tree is actually, so that's what we are trying to achieve now then. And this function, it takes this and it returns extract, right? No. Oh, or it returns nil. So now, and here, what do we need to do then? Let's for now try to, so this stuff now renders things, right? Let's commit it as well, just to not do and package reconstruction. So now we can do this stuff with confidence. We won't lose our progress. Here, essentially what we need to do a count. And in this count, we can then call section start. Actually, no, that won't be bool, right? So how to write it better? We can do, well, I guess cases are cases. If it's language section start, we then need to, on this element, it can be two things. It can be this with language name, new language name in this case. And here we already know that it's indeed true in the element. Or it can be nil. Oh man, that will be funny to do because if it's same stuff, we know what we need to return. And here we can do this now. And in principle, that should be the same. Yep, it is. So now you see our logic already starts to look a bit better. We now have this like more semantical representation of what we're trying to achieve. And we extract elements here, and here we just only care about attaching stuff to results. Now, of course, it's still not very user-friendly to add those sections, and it doesn't like something. The pattern can never match the type. Yeah, it can. It's kind attribute element and element type nil. Well, we already have it. I wonder actually if it will understand if I switch it. Or maybe it's some kind of weird, but fine. Okay, I won't care about that much. Let's just put it back. Now, what do we want to extract from this thing? First, let's extract the grammatical thing, right? So that is somewhere. So we have the whole pronunciation things that I don't care about. Yeah, so each section, you cannot really see it well, I guess, but each section is H3. Then you have like span with class NV headline and the name of the section. And then the stuff inside is actually, I know, and then you just have its children following it, not inside it. Here, we essentially want to extract stuff that is like H3. Yeah, this logic, what it will do when it detects a new language section, it will update the language name here. And it will put all the following nodes in the list under this, like, in the separate list, essentially, with the language name and the HTML3 nodes. We probably will need to have the same exact logic for example, each section of noun or like verb for each grammatical kind we can have. And for that, we essentially need to write another extractor, right? So we have language section start, and we can say word. Okay, I really need to look up because so a noun is words with functions. Part of speech. Oh God, I'm so dumb. I forgot this. So to speech section start, right? So it will have exactly the same kind of type. And in essence, what we need to write here, we need to take this MW headline stuff and see the ID of the node. So it will be very similar, right? We will have still like, if it doesn't match, that's the case. Otherwise, that's the thing. We probably will need to extract this logic a bit more too. So it's H3, which has inside a span. And that span attributes. One of them is class. Actually, I think we can also do easier comparison, right? So we say, is it like exists? I don't remember if we can test it, but let's try. So let's create a simple list with like something like that. I don't know. And see if we can use in on that. So true. False. Okay, good. So then we can actually simplify this stuff. Okay, for now I ignore it. We can just say this in. Will we get the same result? I guess so. And so that is simplified, and I think that we can even do here, right? So then this stuff we won't need either. No. Okay, so that sadly won't work. But still, it looks a bit better. And in this case, we can do pretty much the same. So we can change it to be that. In. And so you have this stuff, and we then can also do if. Oh yeah, interestingly enough, let me check some other articles. So let's search for what word can we use? Yeah, Schadenfreude. Because I noticed that in the following language sections, it doesn't give it ID. You cannot have the same ID multiple times on the page, right? So they write like first header with noun is ID equals to noun. Next is ID equals to noun underscore 2, which is interesting. But then here we still will need to do the enum any. And then we will say span attributes, and here we will have functions that takes attribute. We can actually just do it like that. We can say ID string starts with noun, or even and if that is not true, then we can false. So that's our other condition where we just say, okay, if it's a headline, and if we have an attribute which is ID, and the ID starts with noun, ID name starts with noun, then that's what we're looking for. So actually, part of speech. I want to go back because I figured out that that probably will be the logic for all of those, right? So I'm looking for a verb now. Actually, I think English is easier because there are a lot of words in English that are both verbs and nouns. In German, I think it's not even possible. At least they will be written differently because nouns in German are also always written with big letter, but with capital letter. But in case of English, it should be a bit easier, I think. We can arrival. I'm just trying to find some word. Maybe yes. So like. And here, oh, in this article, they have like different, wow, oh my God, this is so crazy because apparently each article really has a different level of internal thing, because here on like angst article, the part of speech thing is H3. In like article, it's H4. Man, that will be really fun to parse. And I wonder, so if we go to Danish, here it's H3 again. Fun. But yeah, it's H3, and here they have span ID is noun 3. And in verb, it's verb 3. So yeah, they have essentially, we can create a module attribute, parts of speech. And here we will have what kinds of parts of speech we have. We have they're always capitalized that, right? So noun, verb, adjective, I guess, adverb, adjective, pronoun. I wonder, I forgot how to call the end thing. Conjunction. I'm pretty sure there are some more exotic things and things that I'm forgetting right now, but I think for our purposes that will be sufficient. What don't you like? Size. Misplaced operator. Oh, yeah, we don't need it, so we can do it like that. So then I guess so here it will be part of speech or nil, right? We will just do enum find, where we take span attributes and we take a function. So you'll do it the same way. And then for each of those, right? So that's like our part of speech or nil. And then if it's nil, we still return nil. And if it's not nil, then it's part of speech. And we return the result. So, and that will be part of speech section start. Part of speech and element. So we need to update our definition of possible elements, of possible kinds. And then, so now we have those two things, right? We have languages and we have parts of speech. For the fun of it, I will do one thing. It will be incorrect, but bear with me because I think we are getting close to some kind of breakthrough here. So this stuff I will comment out for now. So we only get languages, right? Such beauty. Okay, so that's our titles, right? I will just add, yeah, it now, by the way, it detects, no, it's still, it doesn't understand. So here, one very ugly thing for now will be that we are doing this like inner case. And that inner case will be part of speech section start. Right? And here, so this is like completely incorrect, but we will see if we actually extracting stuff correctly. If we get speech, and then we can start to refactor that, right? So I will just do that. I know it's very ugly, but so now if that works, we should see German, then parts of speeches, then Plattdeutsch, and then parts of speeches, right? Something broke, but let's try it again. Oh. Oh. Part of speech. Ah, I guess we are getting not just the name. Or we get like attribute? So in part of speech stuff, we find it, we say part of speech on nil. Part of speech and element. We can get that, I guess. But the element is the whole H3 thing. Type tuple. It cannot render it or what? I wonder. Let's just do a bit of logic here. So if this is actually, I can do it like that. Oh, or maybe I just need to do a raw language as well, I guess. No, still something breaks. You know what? We just do inspect. Yeah. So we got that. We got the part of speech a bit wrong because we got the ID thing, so span attribute instead of the stuff that we actually wanted. We wanted just this part. I guess. Yeah, because we find this, so we either. Oh, okay, see, so that will be like tag, and this would be like ID. maybe I can do a different thing. So find value, I guess, right? And then okay, that looks better. But I think we're missing one, right? Or don't we? Now noun too. Ah, because we're creating a map. So that's why we are missing one, because we are creating a map of those. Okay, of course we need to create like internal map there, right? But for now, that's already good. So find value solves our problem here. Now we can remove inspect stuff. Now, of course, that's not what we want, right? We want to be able to put, if I type it again, I want to put this noun thing under German and also have it for Plattdeutsch. So one thing that we will need to do, we will need for now to remove the map creation. So that part, it's not what we want. Just take this, we remove this. So then that becomes a thing that we want. And yep, so that fixed it. Now let's try to do the other word. So I want to like noun, verb, French verb, German verb, Hawaiian verb, Norwegian, New Norsk verb, adverb, Scots verb. So that works, which is pretty cool. But we need now to simplify the stuff, and we also need to handle different levels of H3 and H4. So actually, that we can already do, I think. So you can see that now English has those things as well. I wonder why it has verb 2 times, so. Oh, there are like two, so there are like two definitions. There are like two different likes, I guess. Etymology 1, to please, to enjoy, to be pleased, to please, to derive pleasure. And the second one is similar. So that's like different semantic meanings. Okay, that we will need to handle as well, but for now, we can just look at this stuff. We were able to extract parts of speech, and we will need to simplify our logic a bit, I think. First of all, here, I'm also thinking, how should we represent it? Should we still do like a tree structure? Because in principle, all this stuff belongs to language. So language is like the upper things that we select. We select the specific language because that's something we will filter on. And then we have a bunch of sections that will have their own thing. So I'm thinking that maybe our accumulator should look a bit different. So right now you have language name, staged, and result. Instead of just language name, we will need to have like sections, right? So we will have like it can be done as a language name, or it can be like a language name with attributes, with like subsections. I'm thinking that the best way to represent that would be to have like then still like tree-like structure with those lists, but then we will have, let's try to put other stuff there. So I want to have another thing. I will call it subsections. Does it make sense? So like, how should it look? Right now it looks like that. We have like, in theory, it's not really what we have. We have like language, and, or actually we have language, and then we have element. We have language, and we have elements. And I want to move to language and then having a map, I guess. Or maybe for now just even also a list where we have subsection elements. So that would be the structure we want to move to, I guess. But how do we do that? So like if we get, like right now we go through this stuff, and for each children we add stuff to the, we just add stuff to one list. Here it will be a bit tougher to build, I guess, right? Because we will need to, for each subsection we will need to go inside, do that. Okay, let's try to first simplify this stuff, because I think that's an obvious repetition. So let's create a helper function, call it, so we can refactor that a bit, we can move this up. We can call it add to result, where we have current result. Section kind, section name, and we have an element. So that will be the stuff. And here so for now, I will just, I want to check that we get the same result. So I will for now ignore the section kind, but I will still pass it. And here it will be section name. And add to result. Add to accumulator, I guess. Then accumulator. No, I want to do just this basic stuff. So then our result, if it's nil, no, we won't be able to extract it so easily, so we need to do that still. So we have this stuff, then if we have case result, we do name. It takes an element. Oh, we actually already passed the element, right? So that's still accumulator. Previous section name. So in principle now I should be able to just write it like that. I can say so we can take this away, and here we can do the same, but oops, here of course I mean part of speech, part, right? Yeah. Part of speech and element. So now let's see. Adjective, noun. French verb, German verb. Hawaiian verb. Verb, adverb. Interjection. Actually, when I'm thinking about this list, we can also make it a bit nicer. So noun, verb, adverb, adjective, pronoun, conjunction, interjection. So yep, we have extracted it, which is good. And now our body of this function looks a bit better. So here, yes. Let's try to just, for now, I'm almost running out of time, so I will just try to make this stuff a bit nicer. This will be our next to do. We will need to put subsections under corresponding language section. But we are getting closer, so we don't need to do the whole reconstruction anymore. We can just, yeah, actually, do HTML. We don't even use it, right? I think, do we use it in page? Yeah, we pass article, but article we don't use. So this stuff we actually don't even need anymore. And here then, can move it also a bit up. Here, can we make it a bit nicer? So like, tag attributes. I wonder if this is actually correct, because I think we probably will have some words, some articles where language is not second, or maybe it always is. So Oh, it's like span ID is the language ID. I see. Well, at least it's the same kind of thing. So we can, of course, always take languages themselves. List of languages. Let's just also add to do here for now. Use ID equal language to extract them. Can we do anything else to simplify this stuff? I don't see it yet. For children, we keep as it is. I will just make it helper. We'll actually make this a helper too. This stuff I will even do TFP. Okay. Maybe I think we can actually try to just put stuff there, right? So section name. Subsection elements. Okay, I guess I will wrap it up for now. Next time we will need to do this transformation, and then we will need to write a bit more parsers to extract the list with definitions itself. And then we can start working finally on showing it up nicely in our LiveView. Yeah, I guess that will be that. Thank you for watching. I hope to do another stream with LiveView and Elixir and this parser stuff next week. So see you then.